Okay, so we're going to start off basically where we left off last week, which is we have our basic game that when you click the flag, the fish falls from the top of the screen to the bottom. If you catch the fish, you get a point under the score. If you lose the fish or don't get it, then you lose a life under the lives variable. So obviously we need to make some changes to this in order to have a full-fledged game. And in doing so, we're going to go over three concepts. The first one is sounds. We want to add some kind of sounds to our game to make it a little bit more multimedia and a little bit more interesting. And then we're going to go over two concepts called clones, which are how we're going to take our fish and make multiples of the fish and make the exact same fish. And then lastly, we're going to go over messages and broadcasting. Messages are basically a way for our game to figure out when something has happened, an event has occurred in our game that we specify. So let's start with the sounds. We'll add some sound effects to our game and then continue on to the next two. So what I want to happen in my game, and it's completely up to you if you want to follow along with this or do something different, but what I want to do is make a sound when Scratch the Cat catches one of the fish. I want to make an eating sound or like a chomping sound or something. When he misses the fish, I want to make like a splat or a pop or some kind of sound to designate that's different from the chomp sound so that you can tell you've missed the fish and therefore lost a life. And then I also want to just have some music playing in the background while the game is playing. So let's start with the music first. That's probably going to be the easiest way to go. So sounds are set up in two different sections in Scratch, depending on what you're trying to do. The first thing we need to do is go to our Sounds tab up here in the middle of our window. Now, the Sounds tab is very similar to the Sprite window in the Backdrop section in that it lists out the sounds that we currently have set up, and then it gives us the ability to add new sounds from our library. It gives us the ability to record new sounds, or we can upload our own sounds, just like we did for sprites and backdrops. So I'm going to choose a sound from the library and just pick a song. I'm going to go to music loops. Music loops are probably the easiest way because it's just specifically done so that the sounds repeat over and over and over again, and most of them have music. Just going to play a couple of these. I think this is the one that I want. So I'm going to choose Dance Around. That's the one I want. And it looks like I already added that to the project, so I'm going to delete that one. But Dance Around is the sound that we want to pick. So now that it's in my sounds workspace, I can go to Script, and I can go to the Sound section. And I have all these different blocks for sounds that we can use in our game and in any Scratch project for that matter. The first one is a simple block called Play Sound with a drop down. And if I double click on it, it plays the actual sound. And the drop down lets me choose from the sounds that are in my container. I've also got this second block which says Play Sound Until Done, and then a block for Stop All Sounds. Now, the difference between the Play Sound block and the Play Sound Until Done block, we'll see it in just a second, but it's just like it sounds. This will play the entire sound all the way through and then proceed to the next action, whereas this one just starts playing the sound and then immediately goes to the next action. It doesn't wait for the sound to finish. So in the case of our game, I want to put in a loop first that plays the song over and over and over again so that it doesn't just play the song and then stop. We want it to play continually while people are playing the game. And if I do that with my forever block on the stage and put in my play sound block, what'll happen is you'll just hear kind of a ticking sound. And the reason that's happening is because, as we mentioned, the play sound block doesn't wait for the sound to finish playing. So what happens is this forever loop just immediately runs over and over and over and over and over again, a millisecond apart. So you get the first millisecond of the sound, and then it restarts again and plays the sound again and again and again and again and again. So in order to get the song to play all the way through and then only start again once it's all the way through, we want to use the play sound until done block. So now if I start the game, I'll get the loop. Okay, now we also have some additional blocks. We're not going to use these in this current project, but I do want to go over them quickly. There's drum and rest blocks. These literally play a drum beat. When you double click on them, you have a selection of different types of beats that you can play, and then the duration, how many seconds it plays for. So in this case, it would play a tambourine for 1/4 of a second. Okay. We also have a rest, so if we're trying to put together an actual song or composition, we can put silence for specific periods of time. This is kind of like a wait block for sounds. We can also play notes, which have a piano keyboard that you can specify which note you're playing, and then for how long you're playing that note. And then we can change the instrument for those notes as well. So you can play an electric guitar, and if we double click on that and then play, we'll get the electric guitar sound. Okay. You can also change the current volume for the sounds in a stage, and also the current volume level as a variable. We've used variables a little bit, so this should be something that you already kind of understand. We've got tempo blocks as well. This just changes the speed that these notes and beats and instruments play for. So if you want to increase the tempo, you can change it by a certain amount, or you can set it to a specific amount. And then just like with the volume, we have a variable that gives you or returns the current tempo. So if you ever need to find or know what the current tempo of your song is, you can use that. All of these blocks down at the bottom here, starting with the drum block all the way down, people frequently use these to create like drum machines, so that if you use events like when a specific key is pressed, you can play a specific note on the keyboard or a specific drum sound. So that way people can put together instruments or recording programs using Scratch. Okay, so we've got our play sounds, we put them in there. Our game is now playing a sound when we play it. So now we're going to go through and put sound effects for each of our score sounds and then our miss sounds, or our you lose a life sound. So in order to do that, we could technically set up the logic for this anywhere on any of these sprites, but because our fish sprite is already determining whether or not we've scored a point or whether we've lost a life, we're going to use the fish sprite in order to set up our sounds. And we're literally just going to drag the sound that we want into the section that we already have. So you can see that I've already loaded the chomp sound into our game. So I'm going to take this block and I'm going to load the chomp sound when Scratch the Cat is touching the fish, or I should say when the fish is touching Scratch the Cat. So now every time I start the game, you hear a chomp sound when Scratch catches the fish. And conversely, on the opposite side, we're also going to play a sound. I'm going to load a sound from the library. Let's see if there's a splat. Stat maybe. Maybe an ow. I think we'll just use the pop one. That's the default sound that gets loaded in the sound library. So we'll just use that one. We'll use the pop sound. So again, I'm going to choose pop from the drop down, and then I'll move that into our sound camera. Oops. Looks like I've already got that there. Okay, so now if Scratch the Cat touches the fish, which increments the score by 1, we're going to play the chomp sound. If the position of the fish is above our floor limit, then we'll move the fish downwards. Otherwise, once it hits the floor, it's going to play a popping sound. It'll hide the fish, and then it'll change the life by 1 and stop our script. So that looks like it's working. Okay, so now our next step is to make, instead of just one fish appearing, we want to have multiple fish appearing. And here's where we get into our next control block, which is called clone. When I start as a clone, these are the last 3 down at the bottom. When I start as a clone, when I create a clone of myself, and then delete this clone. Now, clones, kind of like the name sounds, are exact copies of a sprite. We could technically make new sprites that are the exact same one just by duplicating them over and over and over again, and then assign them to our stage and set up the parameters of where we want it to spawn and how we want it to fall. But in this case, our fish is already spawning in a random spot, and there's not really an end to our game. So we technically don't even know how many fish we're going to have by the time the game is over. Technically, the player could keep going on and on and on and on and on. So we're going to have an unlimited number of these fish getting set up. So what we want to do is set our fish to create clones when the game starts. Okay. So we'll start by using our when flag clicked block. Now, I could technically put it into this when flag clicked block, but because this logic here is separate from the logic of creating new fish, I'm going to set this up separately, and you'll see exactly why in a second. But what I want to happen is when the flag is clicked, I want to cause a forever block to create fish over and over and over again forever until the game is over. Until, in this case here, we stop the script. Okay. And actually, I think it's on the stage. We'll need to stop the script when we lose all of our lives. So what I'll do is I will take our forever block here, and I'm going to create a clone of, you'll notice there's a drop down as well. So I have myself or fish2. In this case, because I'm on the fish2 sprite, both of these will do the exact same thing. I'm going to explicitly choose fish2. Now, like we've seen in the past, this will fire immediately. So if I start my game, I'm going to get a whole bunch of fish that fall one right after the other. So I do want to use a wait block here so that there's at least a time frame that changes between fish falling. In this case, I'm just going to leave it at 1 second, and then we'll see what happens. Okay, so you'll notice that something happened. Our clone of our fish got created. You see them up the top. You don't see any of the multiples because they're stacked on top of each other. But the action that our fish performs only happens to the first one, the one that's already on our stage. And the reason for that is because this set of logic here only happens when the flag is clicked. Okay? And when these clones are created, the flag isn't clicked. It's already been clicked. So we have a special block here, a special start block called when I start as a clone. Okay, this block is exactly the same as the when flag clicked block, except instead of starting when we click the flag, it starts when that clone is created. So if I grab all of this logic, all of these blocks, and just move them to the when I start as clone block, and then get rid of that, it'll perform the exact same thing, but now it'll do it for every single one of these fish clones. So if I start my game, I should see my fish falling. Now you'll notice that our fish keep falling. We haven't put in any logic to end the game when we run out of lives or anything. So it'll just keep going into the negative, and that's one of the next things that we'll have to set up. We'll have to create some logic to deal with what happens when we actually run out of lives. But for now, it looks like our game is working. We've got all the fish falling where they need to fall, when they need to fall. We've got multiples falling, so now we have a little bit more of an actual game. Now, there's some issues with our game, or not necessarily issues, but we may want to improve a few things about the game. One of the things that I want to improve right away about the fish is their speed. The fish all fall at exactly the same speed, and it starts off pretty quickly, but it stays constant. No matter how many of these fish we catch or how well we do, the game basically just goes on forever. And actually, while I'm thinking about it, because it's playing in my ear, I also temporarily want to remove the music, just so that it's not playing while I'm testing. We'll snap this back before we're ready to share our game and make it live, but for right now, I don't want that playing, so that when I'm testing, I'm not hearing that same loop over and over at the beginning. Okay, so how can we make our fish change their speed? Now, one of the things that we see in our code block right now is that our fish's position, the speed that we're actually moving the fish, is -10 pixels or -10 steps per loop. So technically, that's our speed of our fish. So instead of setting it at a constant -10, we can set up a variable like we did for the lives and the score in our X position for our fish. We can set up a variable for our fish speed. Okay. Now, because we're using clones and that fish speed applies to all of our fish and not just one specific instance of a fish, we want to make this variable a global variable. We want it on our stage. So I'm going to click on stage, click make a variable, and make a variable called fish speed. Okay. Now, the reason, again, that we're setting up that variable as a global variable is because when we create our fish, if that variable is local just to the fish, every single one of our clones will have its own copy of fish speed. Okay, we want all of the fish's speed to change at the same time, not individually, so that as the player does better, we can probably set it up so that every time the player catches a fish, the speed goes up. I'm probably going to set it up so that it changes every 5 or 10 fish. But we want all of the fish that are currently on the screen to change their speed at the same time. We don't want to have to go through every single clone and update the speed when the player catches that number of fish. So we'll start with 1 fish for every speed up, and you'll see how that's set up, and then we'll modify it so that it changes only when the player catches every 10 fish or every 5 fish. I think we'll do every 10 fish. So right now we have a fish speed, and on our stage, we've set our lives here, we've set our score here. So we're also going to set our fish speed here. And I'm going to start it off, again, we were at -10 initially. I'm going to start it off at a really easy value so that the fish move pretty slowly. So fish speed is going to be -1. So now, in the spot where we're changing our y value, instead of keeping it at -10, I'm going to use that variable. I'm going to use that fish speed so that whatever we change here, or whatever we change that variable to, that will update for these fish. So hopefully, if we start our game now, the fish should start falling 1 step at a time, and then when we put in the logic to speed that up, it'll fall faster. It looks like it's working. Again, every 1 second, we create a new clone. And you can see our variable over here listed for fish speed is -1. Okay, so far so good. So now what we want to happen is every 10 fish that are caught, we want to speed the fish up so that they fall faster. Okay. And there's a few different ways that we can do this. I'm going to do it using our stage, our level. Because our level is keeping track of the lives and the score, we can easily check what the score currently is. We have that variable set up, and then we can make our adjustments to fish speed, which is also a global variable based on that score. And again, global variable just means that every single one of our sprites or every single one of our items in the game can access that. So technically, if we wanted, we could make further modifications to this speed depending on what things happen. If we eventually had Scratch the Cat catching different kinds of fish, or maybe there were different items that hurt Scratch, or maybe some objects that the only purpose that they had was that they sped things up, we could still control the fish speed from any item or any object in our level. Okay, so I'm going to make a loop in our forever loop here. And I have a few different ways I can do this, but I know for certain that it's going to start with an if block. I need to check if something has happened and then increase, or in this case, decrease our speed variable. So if something happens, in this case, eventually what I want to happen is if the player has caught 10 fish, then change the speed. So I'm going to change my fish speed, and I'm going to change it by -1. Again, because the Y value is it goes down the screen, it's a negative value. I want to change my fish speed by a negative amount, and I only want to make it one step faster each time. Okay, so now I need to figure out how do I actually get that condition to happen. Okay. And again, I have a few different ways that I can do that. I can either look at my steps here out how to get that 10 value if the player has caught 10 fish. Okay. And I'm already keeping track of how many fish the player has caught with the score. So here's where my operator blocks come into play. We used operator blocks a little bit last time to set up our less than, equal than, greater to, in our addition, multiplication, division. We actually used the random block to set up the position of our fish in the X and Y coordinates from last week. So this week we need to check to see if the score is a multiple of 10. Okay? There's a few ways that we can do this. We can either check manually if our score is 10, 20, 30, 40, 50, 60, 70. But again, because we don't know how high the score can go, we need to do some math to figure out whether or not the score is divisible by 10. Okay? And here's where we're going to run into a problem. If we just tried to use our division operator and check if the score divided by 10 is equal to something, what we'd find is that Scratch doesn't do division. Actually, no program languages do division the way we're typically taught it in school. When we have something like 5 divided by 10, okay, normally you would get 2. 5 goes into 10 2 times. Okay? But what if we divided 10 by 3? In school, we're taught that it's 3 1/3, or 3.333333 repeating. Okay? In programming, the division operator, when we divide two whole numbers, drops anything after the decimal point. So in Scratch and in most programming languages, 10 divided by 3 is actually just 3. It doesn't round up, it doesn't round down, it just lobs off and drops anything after the decimal point. Okay? So even though there's technically a remainder in division, in this case 3 goes into 10 3 times with a remainder of 1, that remainder is dropped. The decimal point values are dropped. So we have a special block or a special operator in coding and in Scratch called the modulo operator. And the modulo operator is sometimes called the remainder operator, because what it does is instead of dividing one number into another and then giving us how many times that first number goes into that second one, or the second number goes into the first one, it gives us the remainder of the division. So if we look at what we're trying to accomplish, which is we're trying to see how many times, or we're trying to make this change every time we get to a multiple of 10, if we use x modulo 10, that means that whatever number is here divided by 10, and then it will give us the remainder. So our actual if condition is going to be something like this. If our score divided by 10 doesn't have a remainder, or in this case, the remainder is 0, that means that we have a multiple of 10. If we divided it by 10 and we got a remainder, that means it's not a multiple of 10. So 11 divided by 10 is 1 with a remainder of 1. That's not a multiple of 10. So our remainder would be 1, not 0. But 20 divided by 10 is 2 with a remainder of 0. So in that case, the remainder would be equal to 0, and that satisfies our condition. So if I drag this in here, and then drag this in here, now our stage is checking all throughout the game if the score is divisible by 10, then change the fish speed by -1. Okay. Now, before I hit the green flag, I'm again going to preface it by saying that we may notice an issue right away because this is going to happen every single time. Right now, our score, if we start our game, is 0, and 0 divided by 10 is 0, so the remainder is 0. So our fish speed is actually going to change immediately and go on forever, and we'll see that in just a second. So our fish speed is going pretty quickly. So I actually need to make a change here. We need to move this block into our condition for where Scratch is actually catching the fish. Okay, we can move blocks from sprite to sprite or from stage to stage just by clicking and dragging them on top of a block. Okay, so you'll notice it's snapped here back on the stage, but if we click on the fish, it'll also have a copy here now. Okay. Now, you might wonder why we started by putting this setup on the stage. As I mentioned before, it's just because we have these global variables that we're using. So I want to put it in context of our stage. We can set up this exact same logic here. If Scratch the Cat is touching the fish, then play, make that happen. But because we've already got that logic set up, it's actually a little bit more organized to put it in this same section. Okay. So I'm going to go back here and delete this. I'm going to keep that forever block because, again, our music needs to go in there. But as I said, we could technically set up that same logic in here. Since this is a global variable, we could set it up here so that everything that happens stage-wide happens in this section. But because the fish has access to those, it makes a little bit more sense to put it in with all the other fish criteria. So now if we play our game, we should see our fish speed increase after every 10 fish. There you go. Okay, so we did see the increase there. And you might have noticed that the speed increased when we first caught the very, very first fish, and that when we get to our multiples of 10, like 30, it doesn't actually speed up until we catch the next one after that. And that just goes back to our order of operations. Right now, we're checking if Scratch has touched the fish, or if the fish is touching Scratch, play the sound. If our score is a multiple, change the speed, and then we change the score. So we actually need to flip these around. We need to change the score first, and then check to see if our score is a multiple. So now if we play it, we shouldn't see any speed up here in our fish variable when we catch that first fish. So far, so good. Now we should see it speed up. Okay, see all of the fish are speeding up at the same time. Again, that's because we set that speed as a global variable. So all the fish change their speed at the same time. 30, it should speed up again. Okay. So it looks like we've got our fish speed working. Now, we could take this even further and play around with the timing delay of our clones. I'm not going to do that right now, but we could set up another variable for the time. Maybe since our fish are falling a little bit slower, we want to give it more time in between clones. And then as we get farther and farther up, we want that time to shrink, go faster and faster and faster and faster. That's up to you if you want to create that. We're not going to set that up now, but it is a possibility. All right, so our next step is we need to figure out how to set up our game so that it ends when we run out of lives. Okay, right now our lives go down the way that we kind of intend for them to go down, but it goes past 0. Okay, so we need to do something once the number of lives that Scratch has hits 0. Okay, again, we can set up our scripts here with our global variables. I'm going to uncheck fish speed because I don't really need to see it anymore. We can have that happen with our global variables, but because our fish already has the logic set up for when the score changes, okay, I'm just going to add that logic here to this section. I can create it here and then move it here if I want to, or I can just create it right here. Okay. So what I'm going to do is I'm going to set up a script that says, and I'm just walking through this right now, if a fish hits the floor and Scratch has 0 lives left, then stop the entire game. Okay, so I've already got the logic here for the fish hitting the floor. It makes a pop sound, it hides the fish. Okay, so I'm going to grab my control blocks, put in another if block, and I don't want it to wrap in this case because I want this stuff to happen no matter what. Okay, but in this case, actually I want my lives to go up above that. So if Scratch misses the fish, it hits the ground, he loses a life, and if his number of lives is then 0, we want to stop the game. So again, I'm going to go into my operators. I'm going to pick my block, and I'm going to set this up so that our lives equal 0. If our lives equal 0, stop the game. Okay. Our stop blocks are under the control section. So I'm going to use the stop all block because it will stop all of the scripts. It'll basically stop our game. It's the same thing as hitting the little stop sign. So now if I wait for the fish to fall. Now, while we're testing this, obviously the fish are falling kind of slow. So I'm actually going to go into our stage and set our fish speed to -10 so that they fall a little bit faster. Just helps with testing so I don't have to wait around for it. Okay, so notice how our lives, when it hit 0, stopped. Try one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're out of lives. Our game automatically stops. Okay, our score is still updating when we play. And if we miss the fish, our lives go down each time. And again, as we mentioned, when they hit 0, game's over. Okay. So now we have a couple other things that we need to change. We don't have to set anything with our score and our lives because we've already set that so that the score resets every time we start the game. We reset the position back to the mouse when we restart the game, so that works the way that we want it to work. But now we want to have something that can actually restart the game without the player having to hit the flag over and over and over again. We may want to have a button or something that pops up in the middle of the screen that allows you to restart the game when you get to it. So in order to do that, we need to create a new sprite for the button that we want to press when the game is set up to restart. So I'm going to, again, choose a new sprite from our library. I'm going to create a button. We've got a couple buttons here. I think that's the way I'm going to go. We also have a home button that we can use. But I think I'm just going to use one of these buttons. I'm going to click button 2, put it right in the middle of the screen. And I can also paint a new sprite, or I can take this sprite and under the costumes section, I can paint on here or edit on here. So I'm going to change this so that it says the word restart. Make the text white. And I'm going to move it in the middle. Stretch this out a little bit so it's a little bit bigger. And that's automatically saved. If I go back to my scripts panel, you'll see a little message that Scratch has saved your button. And now I have a button that I can use to restart the game. Okay, now how do we actually make this restart? So one of the things that we can do in Scratch, we've seen already that we have events like when the flag is clicked that basically cause something to happen when we click the flag, or we can have the space bar do something when we click it. We also have a few other events that can happen. One of them is when the sprite is clicked, which is what we're going to do on here. But we also have blocks down at the bottom here called when I receive message. And then below that, we have some broadcast message and wait blocks. Now, messages are basically custom events. We decide when that event happens. Okay? We decide what happens to the game. And when those things happen, we can cause other sprites to do something. Okay? So what I can do is I can grab the block when this sprite is clicked, which just like it sounds, when I click this restart block, something happens. Okay? But by putting a set of steps here when that sprite is clicked, I can only control what happens to this sprite. Okay? I can't cause anything to happen here when this button is clicked. There is no block for when the restart button is clicked. It's only when this sprite is clicked. So what I need to do is create an event. I need to set up an event that says when I click this button, restart the game, and then under all my other sprites, I need to set up something that says, hey, when I restart the game, do this. Okay, and the way I do that is with something called messages. Okay, messages are custom events that you can name just by clicking the little drop down and creating them. So if I click on new message, I can create a message called restart and broadcast that message when this sprite is clicked. So now what that does is when we get to this part of the game, we click that block, it sends out a message to everything in Scratch that says restart. So now, under my fish, I now have a block that says when I receive that message restart. So when something in my game broadcasts that restart message, these are the set of steps that I want to happen. Okay? And in this case, we already have some of that stuff set up. Okay? What we want to happen is we want our fish to all go away, and we want our level to reset itself up. Okay, so right now, when we play our game, and we'll fix the button just kind of hanging out in the middle there. Actually, let me change our fish speed back to -1. What you'll see happen is if I have fish on the screen when I hit my life limit, okay, our game stops, and we stop all of the scripts that we have happening. So our fish position no longer changes. We stop everything. So now what we can do is just to make sure we can tell the game to delete all of the fish. If we were to restart our game, now no matter what happens, if we run out of lives, all of our fish get deleted. It's already kind of happening because we're going to stop the script. Because we don't actually want to stop the game as a whole, we just want to give the player the ability to restart the game. In fact, let's remove that just for a second so you can see what happens here. Okay, we need something to happen where our old stop all command was. We need to restart the game. So under our button, when this restarts, when the sprite is clicked, first thing we're going to do is hide that button, which is under looks. And then we're going to broadcast that restart, which deletes all the fish. And then because there's no block under control to start the game back up again, there's no block that says hit the flag again, we need to make a game over message. Okay. So again, we're going to go into our events. I'm going to remove this stop all. We'll put our broadcast block there, but create a new message that says game over. Now, when our lives hit 0, we want game over to happen. We want everything on the screen to stop. And we want the restart button to pop up. So the first thing we need to change is the fish. When I receive game over, stop this script. So in this case, we want to stop just what the fish is doing. We don't want to stop the entire game. We just want to stop what our fish is doing. Okay. We also want our restart button to pop up on the screen. Okay, so when I receive game over, show our restart button. Now, when I hit the green flag, you'll notice that it's already showing. So we also need to put in a when flag clicked hide, which will hide our button when we first start the game. But now when we run out of lives, our restart button pops up. Our fish keep going though. Sorry, we need other scripts in the sprite, not this specific script. So we have some options here under the stop block, all, which stops everything in the entire game. This script, which stops the specific script that this block is a part of, or other scripts in Sprite, which stop all the other scripts that we have going on here. That's the one we actually want. So let's try that again. Okay, Scratch the Cat is still moving, which means our game is still running. And now we have our restart button here. So now, when we click restart, our message should fire because we've set up our restart block. When this sprite is clicked, hide the button and then broadcast that restart. And we've set up our restart message here so that when the fish receive restart, they all delete. So let's see if that worked. Okay, so all the fish disappear. Scratch is still moving. Our game is still running. Now we need to make sure that those fish start up again. Okay. So in order to do that, we're actually going to take another restart block. And we're going to grab our forever block here and just move it. Okay, we could copy it too, but because we're using messages, we can actually just drag that over here and then broadcast a restart. Even though it's technically the first start, it's the same actions, the same set of steps that happen. So let's try that again and see if it works. We're going to stop. So far, our game is functioning the way it should. Our game stopped. Still going, but the fish have stopped moving. And when we restart, they're killed, or the clones are deleted, and then the game restarts. Okay, now here's where we may run into another issue. What happens when one of the fish falls? Okay, you'll notice our score is already in the negative. If I stop this and restart it, I'm going to let these fish fall on purpose. But watch what happens after we restart the game. So our score is 0, our lives are 0. I restart, my score doesn't reset. So I need to do the same thing that we did here. And you might be wondering why we used a second restart block instead of just using them when we already had. Some blocks in Scratch, you'll notice that these here have a little nub down at the bottom, a little puzzle piece connector, and some of them are flat at the bottom. The flat ones are end blocks. You can't continue anything on them because there's no other action that can happen after that happens. If we delete a clone, we can't have something happen after that because it's been deleted, it's been removed. It's a final block. Same thing with forever. Because a forever block repeats over and over and over again, there's no end to it. We'll never get to a next step because it just keeps going over and over and over again. So these two blocks can't be used in the same message. So we technically have to make two different messages. So now let's go into our stage and set up that reset of our score as well. So when I hit restart, do the same thing. We're going to set our lives back to 9. And what you'll see is that we're actually doing the same thing as our setup steps again. So let's just grab those and move them there. And where we used to have this, we can broadcast that message again. Restart, just like we did with the fish. Okay, we moved the block from here and then replaced it with a broadcast. We're going to do the same thing with our score. When you receive start, set the lives to 9, set the score to 0, set the fish speed to -1. That resets everything in our game back to where it was before. If we play, I'm going to catch a couple fish to test. And then I'm going to let the rest fall. Fish start falling again. Our speed still works. So now I've doubled our speed. Now I'm going to let the last 4 fall. And just make sure that when we restart, our speed resets. So now we have an actual game. We have a win condition. It's like Tetris, you can go on forever, but your score is the win condition. We could put in some additional logic with variables to keep a high score. We have a lose condition. You run out of lives, the game stops, it's over. And we have a restart condition. Again, we've done that using our broadcast and our messages. Okay. So now it's just a matter of playing our game and seeing if there are any other bugs. I'm going to move our music back into place. I'm just going to double check all of our logic here. And I'm going to start playing. So that brings us to the end of teacher training for week number 3. You've got a basic game. We're going to continue on with some different sprites and some different blocks next week. We're probably going to make a slightly different game. But next week, we're going to talk about setting our games up for mobile. And you'll see some of the problems that we'll run into with this game. We'll start with Kitty Drop, which is the name of our game here. We'll put it on a mobile device, and you'll see what happens and what kind of special considerations we need to take when we're making an app for a mobile device or a tablet or something like that. Okay, thanks a lot for joining us. Have a great week.